One of today's greatest and most advanced physicists has now spoken out. Michio Kaku confirms that the James Webb Space Telescope has just discovered 6 massive galaxies that scientists previously thought could not exist. These findings have the potential to add whole new dimensions to our scientific understanding of the universe. So stay tuned because it's going to get exciting. The opinion of an exceptional physicist. Michio Kaku is an exceptional figure in the world of science. The Japanese-American is considered an expert in both classical experimental physics and quantum mechanics. Kaku is not one of the old scientists who are reluctant to admit anything new and still doubt or question the staggering results of the James Webb mission. We are delighted that this important man has finally broken his silence and spoken out quite publicly what can no longer be denied. Exhilarated, almost amused, the star physicist comments on the discovery of the James Webb Telescope by saying that JWST was the straw that broke the camel's back. What exactly does the scientist, who was awarded the Distinguished Public Service Medal by NASA, mean by this? Well, Michio Kaku is a scientist who has been open to new theories all of his life. Kaku has always been aware that Einstein's equations of relativity and Newton's laws can never even come close to reflecting the full complexity of the universe. Kaku knows full well that the discoveries of the new telescope can only make the world of science richer, even if many of his colleagues have so far been absolutely unable to share this view. What is currently causing hardcore proponents of the Big Bang Theory and opponents of quantum mechanics sleepless nights only makes Michio Kaku laugh. The multi-billion-dollar telescope has discovered 6 giant galaxies from the beginnings of the universe. Each one of these 6 galaxies contains more stars than the Milky Way, even though they were formed only 200 to 700 million years after the Big Bang. The team of astronomers who discovered these galaxies dubbed these cosmic exceptions universe breakers, because if they are real, they will turn our entire knowledge of the universe on its head. Too bright, too big, and too many stars. The discovery of these galaxies is no longer compatible with the old cosmological worldview. Nobody believed so far that the young universe was able to organize itself in such a way that large galaxies with billions of stars existed. According to previous models of star formation and galaxy formation, there was no time for this at all. The cosmos is supposed to be 13.8 billion years old, and these galaxies already existed, fixed and ready, enormous and enormously bright, to the assumed cosmic dawn. Something cannot be right here anymore. The theory of the Big Bang tells us that the cosmos was a boiling hot soup after its initial event. It took hundreds of thousands of years for the first solid objects to form, and another few hundred million years were necessary for objects to reach such a density that they produced light. Complex orders like galaxies may have formed much later. Some of the newly discovered galaxies exceed the size of the Milky Way, and the enormous luminosity of these supposedly young galaxies indicates that they probably formed hundreds of new stars each year, while our galaxy forms new stars only sporadically. When exactly the first galaxies were formed, researchers could not know until now. It was only clear that in the beginning, there could have been only single stars or star groups. These found themselves together finally to ever larger accumulations until dwarf galaxies developed. These met again with other small galaxies, and slowly the galaxies grew. 200 or 500 million years after the Big Bang, highly organized and massive galaxies cannot possibly have existed according to these assumptions. This means now that the universe is either much older than assumed so far, or that complex star arrangements in galaxies developed already much earlier. It is exactly recognizing this circumstance that conservative science finds at the moment still very difficult, and some branches of physics refuse vehemently against the discovery and suspect errors in the age calculations. Michio Kaku knew it. A quote from Michio Kaku: "There are many examples of old false theories that stubbornly persisted, maintained only by the prestige of stupid but well-connected scientists. Many of these theories were eliminated only when a crucial experiment revealed their falsity. Therefore, the fundamental work in any science, and especially in physics, rests with the experimentalist, who must keep the theorists honest. The fact is that we on Earth know very little about the actual beginnings of the cosmos. The Big Bang Theory originated in 1927 based on observations of the expansion of the universe. These data allowed conclusions to be drawn that the cosmos originated from a single point of origin and has been expanding ever since. It was in the nature of the people and the scientists at that time to be able to imagine things only with a beginning and an end. A universe that always existed and is infinite in time as well as in space was beyond the imagination of those people, and until today, even scientists have difficulties with it. Nevertheless, also these possibilities must be considered again. This does not fit at all with researchers who base their work on the Big Bang Theory for decades up until this moment. But science has shown time and again that rethinking and new findings are just as much a part of the process as confirming certain assumptions and observations. When Einstein was a boy, one still assumed in natural science that stars and planets were firmly suspended in the universe, and these determined structures were in a defined space. Today, we already know that everything in the cosmos is in motion. Planets orbit around stars. Stars move within their galaxies at hundreds of kilometers per second, and entire galaxies race just as fast through the cosmos, the end of which is not yet foreseeable. Scientists must now accept unpleasant truths and realize that theories are just theories, and not truths until they can be clearly proven or confirmed by observations. The idea of the Big Bang once arose from the realization that galaxies are moving away from each other, and that this distance is proportional to the distance to Earth. This observation, known as Hubble's law, suggested that the universe was expanding. Elements such as the cosmic background radiation, the redshift of light from distant galaxies, and other cosmological structures long seemed to support this theory. But people who thought the Earth was a disk and the sun revolved around us also had circumstantial evidence for their assumptions until coincidences or an improvement in technology allowed an expanded picture. This is exactly what's happening now, and basically, scientists hope for these realizations from the new James Webb Telescope. Only it looks at present that most scientists had counted on a confirmation of the Big Bang, and not on 6 new impossible galaxies. Michio Kaku's hyperspace. Michio Kaku is a scientist who has always kept up with the times and has spent a lifetime studying the compatibility of classical experimental physics and quantum mechanics. It seems almost unbelievable, but to this day, there are renowned scientists who reject the findings of quantum mechanics, even though they have been experimentally proven better than the Big Bang. In case your knowledge about the world of quanta is not so fresh anymore, we'll help you out here a bit. Quantum experiments showed that our world is becoming increasingly indeterminate and literally unpredictable at the subatomic level. Quanta, which are considered the elementary building blocks of reality, dwell in an undefined state until they are measured or observed. In purely theoretical terms, they can reside in multiple times and places simultaneously. For Michio Kaku, these findings were never a contradiction of the physics of material phenomena and cosmology. He researched unifying field theories and tried to close the gap between the physics of the microcosm and that of the macrocosm. Kaku remains convinced today that string theory may be the answer. String theory, in its basic outline, states that everything in our universe is made up of tiny, vibrating threads called strings. These strings are so tiny that they are invisible to us. You can think of it sort of like how all the things around you are made up of wafer-thin guitar strings that vibrate and oscillate in different ways. The way the strings vibrate determines the property of an object and even a force of nature. Some strings vibrate rapidly, producing particles we know as electrons or quarks. Other strings vibrate more slowly and produce the forces such as gravity or the electromagnetic field. String theory also states that there are more than just 3 dimensions of space. We know the 3 dimensions of length, width, and height. But string theory postulates that there are additional tiny, curled-up dimensions that we cannot perceive directly. Michio Kaku described this world in his work as a multidimensional hyperspace. The special thing behind string theory is that it could be a unified theory that can explain all known forces and particles in nature. Although the theory is plausible, it's rejected in conservative branches of science, just like quantum mechanics. How probable is an error? To stay a bit longer with the probabilities concerning some scientists, we look again at how certain the new realizations are at present. There is a tiny possibility that our previous knowledge of distances and directions of motion in the cosmos has been wrong. Researchers use redshift to determine these quantities. Redshift, also known as Doppler shift, refers to a change in the color of light as the light source and observer move relative to each other. Imagine that you are standing on the side of a road and you see a car moving towards you. As the car moves towards you, you hear the sound of the engine higher and shriller than when the car passes you or drives away from you. This is because the sound of the engine changes as the car moves. It is similar with light. When a light source, such as a distant star, moves towards us, the light we receive is shifted to bluer colors. On the other hand, as the light source moves away from us, the light is shifted to redder colors. This effect is called redshift. The values of redshift have been translated by physicists into velocities and distances. Here, small errors could actually have large effects. The previous measurement techniques are currently being reviewed, and we can be curious to see what results the scientists will come up with. Do you think that the latest findings about our cosmos are actually based on errors in the redshift? Or do you think that some scientists simply want to deny facts?